organic synthesis. Organic synthesis one. Organic synthesis one. Black one, organic synthesis one. Unit one. Functionalization and functional group interconversion and oxidation of alkenes and alkenes. Oxidation of alkenes and alkenes. First, we are going to discuss uh, brief discussion about functionalization of alkenes. Alkenes. Functionalization of alkenes. So alkanes are unreactive towards electrophilic and nucleophiles. The reactivity towards they undergo free radical substitution reactions. Mainly bromination are more reactive than chlorination. Bromination is more reactive than chlorination. Just I am taking one example here. CH3, CH3, and CH3. This is a tertiary hydrogen. This is a tertiary hydrogen. This tertiary hydrogen reacting with bromine at 300 degrees Celsius, then product is CH3, CH3, bromine is the product will be formation takes place. If you are taking chlorine, it again at 300 degrees Celsius, they forms two product will be formation takes place. CH3, CH2Cl plus CH3, CH3, CH3Cl. That means here a primary hydrogen, here primary hydrogen also undergo chlorination takes place with chlorine, and only bromination, that bromination undergo to tertiary hydrogen. That means more reactivity, more sensitivity and more reactivity is bromination is the more reactive than chlorination. Next, functionalization of alkenes. Functionation of alkenes. Alkenes undergo the functionation of alkene is possible at two positions. One is double bond, one is allylic position. One is double bond and one is allylic position. So one is double bond and one allylic position. We are going to discussing allylic. What is double bond allylic? when CH2 double bond CH3. sp2, this is sp2 carbon, and this is also sp2 carbon. Sp2 carbon attached to sp3 carbon. Sp2 carbon attached to sp3 carbon is called allylic position. Allylic position. sp2 carbon attached to sp3 carbon is always allylic position. So alkenes undergo functionation of alkenes involving two positions, one due to the presence of double bond, due to the presence of allylic position. First we are going to discussing due to the presence of double bond. These compounds, when undergo epoxidation with metachloroperbenzoic acid, double bond undergo epoxidation takes place, then forms epoxide is a product. When reacting with oxidation with the alkali KMnO4, Bayer's reagent, the Bayer's reagent, then the product is carboxylic acid and carbon dioxide is a product. When reacting with hydroxylation, when undergo hydroxylation with the osmium tetroxide or KMnO4, then the product is dihydroxylation takes place. When reacting with the bromine dibromination takes place. So a lot of examples are there like this. So oxidation of alkenes is possible. Next, functionation of alkanes. Alkanes, functionation of alkanes. Functionation of alkenes. When alkynes reaction with bromine in CCl4, reaction with bromine in CCl4, then forms a dibromo product will be formation takes place. Trans dibromo product will be formation takes place when reacting with the protonated water in acid medium water, then followed by mercuric oxide, then forms ketone is the product will be formation takes place when reacting with the catalytical hydrogenation. Catalytical hydrogenation, one double bond among these two bond, one double bond under reduction takes place. So another mole of catalyst undergo reduction takes place, then forms two double bonds undergo reduction takes place. So this product will be formation takes place. Next, functionation of aromatic compounds. Aromatic compounds. Electrophilic substitution of aromatic compound is one of the widely used method for the introducing the function group into the aromatic ring. Generally, using reactions or aromatic compounds are summarized below. So, electrophilic substitution reactions are more when electron releasing groups are present in takes place. When benzene ring is undergo different types of electrophilic substitution reaction, there is Friedel-Crafts reactions when reacting with alkyl halide in presence of ALX3, alkylation takes place when reacting with Sl chloride in presence of AlCl3. Acylation takes place. Friedel-Crafts alkylation, Friedel-Crafts acylation, Friedel-Crafts halogenation, halogen in presence of AlCl3 or AlX3, whatever you taken, halogenation takes place. And nitration, when we take in HNO3 and H2SO4, nitrobenzene will be formation takes place, and sulfonation, H2SO4 or fuming sulfuric acid we are taken, or OMIum also, then sulfonation will be formation takes place. Next we are going to discussing oxidations. In generally, oxidation means addition of oxygen or removal of hydrogen is called oxidation. Addition of oxygen or removal of hydrogen is called oxidation. So when we take in alkenes undergo reacting with metachloroperbenzoic acid, oxidation formation takes place. This is one of the example for the oxidation. Removal of hydrogens like dehydrogenation like this examples for the dehydrogenating oxidations. Oxidations are two types. One is introducing of oxygen and removing of hydrogens. We are going to discussing oxidation of alkenes. Oxidation of alkenes. When oxidation of alkene is useful synthetic procedure for to getting a more important in. So generally when benzene ring attached methyl group, when reacting with Na2CO3 sodium carbonate and sulfuric acid, sodium carbonate and sulfuric acid, we are getting the product is benzoic acid is the product will be formation takes place. Benzoic acid product will be formation takes place. That means if there is any one of the benzoic hydrogen, reacting with sodium carbonate and H2S4, we are getting the benzoic acid is the product will be formation takes place. In this case, same when we compound this toluene, when that methyl benzene reacting with when methyl benzene reacting with chromyl chloride CrO2 Cl2 chromyl chloride, that is called Itard's oxidation. When reacting with chromyl chloride, this methyl group attached benzene is converted into aldehyde. This methyl group attached benzene is converted into aldehyde. This is called Itard's reaction. This is a Itard's reaction. It is Itard's reaction. Itard's reaction. Simply, when toluene reacting with HNO, Na2CO3 and H2SO4, then product will benzoic acid will be formation takes place. That means at least one benzoic hydrogen is there. That benzoic carbon is converted to carboxylic acid. When toluene is reacting with CrO2 Cl2 chromyl chloride, the product is benzaldehyde formation takes place. There is reaction is called Itard's reaction. Next one is dehydrogenation of alkenes and alkyl groups. Dehydrogenation of alkanes. Dehydrogenation of dehydrogenation of alkanes. Dehydrogenation of alkanes. So, so this dehydrogenation of alkanes is carried out by using one of the catalyst. This is a reagent. What is DDQ? And that reagent is DDQ. That is where in our syllabus DDQ is a dichloro dicyano benzoquinone. Dichlorodicyanobenzoquinone is the DDQ. Dichlorodicyanobenzoquinone is the DDQ. So by using this DDQ, we are going to oxidize the organic compounds. There is a dehydrogenating oxidation is possible. So the structure of DDQ is CN. So this dichlorodicyanobenzoquinone is the DDQ. This DDQ in this DDQ, this is a six-membered ring is here. This six-membered ring attached to two carbonyl functions and two chlorine atoms, two cyano atoms are there. These are strong electron withdrawing groups. These are strong electron withdrawing group. Therefore, this six-membered ring, benzene ring, is more electron deficient, more electron deficient. To fulfill this electron deficiency, it receives hydrogens. It receives hydrogens readily from allylic and benzylic positions. It receives hydrogens from allylic, and benzylic positions. Yes. So, DDQ in benzoquinone, the six-membered ring is attached to two carbonyl groups, two chlorine atoms, two cyano atoms. So, therefore, this ring is more electron deficient. To fulfill this electron deficiency, they receive hydrogens from allylic and benzylic positions. So, one example I'm taken for is dehydrogenating oxidation is hydrogen is there when reacting with DDQ. When reacting with DDQ by loss of two hydrogen atoms, adjacent positions, one double bond will be formation takes place. One double bond will be formation takes place. This is an example for the DDQ. Uh, so mechanism for this reaction is when this reaction. So this DDQ is a electron deficient, electron deficient, electron deficient. So therefore, this is added ion. Then the bond shifting here. Then the product is your positive charge plus bonds or migration takes place. Cn, Cn, Cl, Cl, OH, O minus. Okay. Now here this hydrogen it is involved in the formation of double bond with the carbon positive charge and elimination of this proton to give the negatively charged oxygen atom of this benzoquinone ring. Then the product is double bond will be formation takes place and and then forms dichlorodicyano benzoquinol is the product will be formation takes place. This is a product will be formation takes place. This is an example. Another example I'm taken here. Best example. Another example I'm taken here. So in this case, here one double bond will be formation takes place from year to year one double bond. For the formation of one double bond, they consumes 1 mole of DDQ. They consumes only 1 mole of DDQ. If I am taken here in this compound cyclohexene, the cyclohexene, when the cyclohexene reacting with the 2 moles of DDQ in benzene is the solvent, 2 moles of 2 moles of DDQ, they forms two new double bonds. They forms two new double bonds. Therefore, they consumes 2 moles of DDQ. For each double bond, 1 mole of DDQ will be consumption takes place. Here, 2 moles of DDQ double bonds will be formation takes place. Therefore, 2 moles of DDQ are involved in this reaction. This is a dehydrogenation alkene and dehydrogenation of alkenes. This is oxidation of the alkenes. The example is dehydrogenation of alkenes with DDQ. Next one is substitution elimination sequence. Next one is substitution and elimination sequence. substitution and elimination sequence. A double bond can introducing in a conjugation with already existing double bond by alkyling allylic hydrogenation. Nothing but, so in this molecule one double bond is there. We are introducing new double bond. We are introducing new double bond with following a substitution and elimination mechanism. But that is NBS. That is NBS. First one is NBS. Second one is quinoline we are taken. So in this mechanism, NBS is a source of benzene free radical. Sorry, the NBS is a source of bromine free radical. This bromine free radical, this NBS is the source of bromine free radical. This bromine free radical introducing at allylic position. Bromine free radical introducing at allylic position. Allylic CH position, bromine is introducing takes place. So by following a free radical pathway, bromine. This bromine halobenzene alkyl halide compound formation takes place. This alkyl halide, when reacting with quinoline, that is a base, act as a base. This base abstract the proton from here and elimination of bromine, nothing but loss of HBr. Then the new double bond will be formation takes place. This addition means we can substitution means we can introducing bromine as a substitution. Second one is elimination of the HBr takes place. There is a substitution and elimination sequence. We are called as a substitution and elimination sequence. Next one is this oxidation. Next one is allylic oxidation. Next we are going to discussing allylic oxidation. Allylic oxidation. So removal of hydrogen from allylic position is easily then from the completely saturated alkene, because the possible intermediate allylic and allylic carbocation or carbanion or free radical is stabilized by the resonance. So that is a example I am taken here. When I am taken allylic position, CH3 CH double bond CH2. This is allylic position. So this allylic position means sp3 at carbon attached sp2 carbon attached sp3 carbon sp2 carbon attached sp2 carbon attached sp3 carbon is allylic position. That allylic hydrogens are more reactive because of when we removing this when we removing this hydrogen, then if the intermediates are the positive charge or negative charge or free radical are stabilized by the resonance. Therefore, these allylic hydrogens are more reactive because of resulting intermediates are stabilized by the conjugation. So when this compound reacting with NBS, previously I'm telling you NBS is a source of bromine free radical. This bromine free radical are introducing at allylic position. This allylic position, therefore that Br CH double bond CH2 will be formation takes place when we take in selenium dioxide. That selenium dioxide is a source, then produces a allylic alcohol. Selenium dioxide is the gives allylic alcohols are the product. OH CH2 CH double bond CH2. Allylic alcohol is the product will be formation takes place with the selenium dioxide. When benzylic positions, the allylic positions and benzylic positions. Benzylic oxidation or benzylic position. So benzene ring attached to sp3 benzene ring attached to sp3 carbon. Benzene ring attached to sp3 carbon is called benzylic position. Benzene ring attached to sp3 carbon is the benzylic position. This sp3 carbon, this benzylic position also more reactive because of resulting benzylic carbocation or benzylic carbanion, benzylic radicals are stabilized by the resonance. These are the stabilized by the resonance. Where I'm going to discussing with oxidation. So of these benzylic positions, so when this benzylic position, when I'm taking toluene, this is a benzylic position. This methyl is a benzylic position. Benzene attached to sp3 carbon is the benzylic carbon. That position is more reactive. When this benzylic position reacting with chromium trioxide in presence of acetic acid, then forms benzoic acid is the product will be formation takes place when this compound reacting with KMNO4, KMNO4, that benzoic sp carbon is converted to benzoic acid. This is a allylic, there is a benzoic oxidation. Next one is oxidation of alkenes. Oxidation of alkenes. First one is formation of epoxide. Formation of epoxide. When in this compound, when alkene reacting with paracids, when alkene reacting with paracids, with this paracids, first then for produces your positive charge intermediate and a state will be formation takes place. This is state observe the proton from here. Then the product is epoxide will be formation takes place. Epoxide will be formation takes place. This epoxide formation is a syn type. This is a syn type addition takes place. This is a syn type addition. Syn type addition will be takes place when double bond, when compound reacting with metachloro perbenzoic acid, epoxide will be formation takes place. Same side will be formed, double bond will be formation takes place. So next one is formation of 1,2-diols. Formation of 1, 2 diols. So by this formation of 1, 2 diols, we are using two oxidizing agents. One is KMNO4. One is potassium permanganate, KMNO4, potassium permanganate. This is a potassium permanganate. When alkenes reacting with KMNO4, followed by hydrolysis, second step, then produces syn or cis 1, 2 diols will be formation takes place. Cis or syn 1, 2 diols will be formation takes place. The two hydroxy groups are at 1, 2 di position, same side will be formation takes place. Mechanism for this reaction is when alkenes reacting with KMNO4, double bond O, double bond O, double bond O. Your negative charge attack it here. Then pi bond shifting to another carbon and going to shifting oxygen side and shifting to manganese side. Then the product is oxygen, Mn double bond O, double bond O. This is cyclic permanganate ester. This is transition state will be formation takes place. This cyclic permanganate ester. This cyclic permanganate ester undergo hydrolysis. In this hydrolysis, the bond between manganese and oxygen undergo disconnection takes place. Therefore, the stereochemistry is written as cis 1, 2 diols. Cis or syn 1, 2 diols product will be formation takes place. Okay. Another example I am taken here. KMNO4. Then the product is cis or syn 1, 2 diols will be cis or syn 1, 2 diols will be formation takes place. So next one is another one for the oxidation of formation of 1,2-diols. One is osmium tetroxide. Next one is osmium tetroxide. Osmium tetroxide. When osmium tetroxide seen, when alkenes reacting with osmium tetroxide, first step, second step is followed by hydrolysis, then forms cis-arsen 1 comma 2 diols are the product. Cis-arsen 1 comma 2 diols are the product. Mechanism for this reaction is when alkenes reacting with osmium tetroxide they forms cyclic osmate ester. They forms cyclic osmate ester. In this cyclic osmate ester under hydrolysis, the bond between oxide and osmium undergo breakage takes place. Then the product is cis-arsen 1 comma 2 diols will be formation takes place. Next one is formation of trans 1 comma 2 diols. Formation of trans 1 comma 2 diols. So this is a formation of this trans 1 comma 2 diols from epoxide. From this is a possible from epoxide. When we take an alkene, this alkene first undergo formation of epoxide with paracids. Then the product is epoxide will be formation takes place. This epoxide again involves in the reacting with carboxylic acid in SN2 manner, then forms trans 1 comma 2 diols are the product will be formation takes place. So mechanism for this reaction is we know already formation of epoxide. Next we are going to epoxide. Next we are going to opening the epoxide. When this epoxide in presence of acid medium, this epoxide in presence of acid medium, lone pair of electron on oxygen donated to acid, then proton, then forms oxygen plus. This oxygen plus involves reacting with the carboxylate from SN2 manner opposite anti-addition. The bond between oxygen and carbon is shifting towards oxygen side. Then the product is OH. Yet ester will be formation takes place. This under hydrolysis then forms 1 comma 2 trans 1 comma 2 diols are the product. This is a trans 1 comma 2 diols are the products. This is trans 1 comma 2 diols are the product. This is another method to preparation of trans 1 comma 2 diols. Next one is reverse oxidation. So formation of trans 1 comma 2 diols. Here three methods are there. So one is with epoxide, one is with epoxide. Second one is we are going to discuss. So two methods are there. Second one is we are going to pre-roast. Formation of trans 1 comma 2 diols. One is epoxide method. Second one is pre-roast. Pre-roast oxidation. Pre-roast reaction or pre-roast hydroxylation. Pre-roast reaction or pre-roast hydroxylation. When alkene reacting with iodine followed by silver carbonate silver carbonate, silver carboxylate, followed by silver carboxylate, then followed by hydrolysis. We are getting trans 1 comma 2 diols are the product. We are getting trans 1 comma 2 diols are the products. When alkenes reacting with iodine, silver carboxylate followed by hydrolysis, we are getting trans 1 comma 2 diols are the products. Mechanism when alkene reacting with iodine, cyclic iodine manage the intermediate will be formation takes place. Cyclic iodine man will be formation takes place. When the cyclic iodine man, when reacting with silver carboxylate, the silver carboxylate attack at iodine position, iodine attached carbon, then bond between carbon and hydrogen shifting to iodine, positive charge iodine. This SN2 manner. Then product is or your lone pair of electrons on carboxylate carbonyl carbon again involves in here elimination of iodine. Then the product is in this compound. It is in this compound again reacting with another more of silver carbonate. Another mole of silver carbonate. Then followed by hydrolysis. Esters undergo esters undergo hydrolysis, then gives trans 1 comma 2 diols. Trans 1 comma 2 diols will be formation takes place. This is a pre-post oxidation. Next one is oxidative cleavage of alkenes. Next one is oxidative cleavage of alkenes. Oxidative cleavage of alkenes. When this oxidative cleavage of alkenes with ozonolysis, involving in ozonolysis. Involving in ozonolysis. When this compound, when alkenes, when alkenes first reacting with ozone, the structure of ozone is like this: O minus, O plus. This undergo 1 comma 3 dipolar addition. 1 comma 3 dipolar addition. Then the product is R, 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 and three oxygen atoms in this compound. This is called melanoside. This is compound is called melanoside. When this melanoside is unstable and bond shifting towards this oxygen and going to here, then the product is double bond O and R R, your negative charge, your positive charge, and oxygen, another oxygen is negative charge. When this compound here like this, again oxygen attached to attack at carbonyl carbon. This carbonyl carbon pi bond shifting to oxygen side. The negative charge shifting to positive charge to carbon. Then the product is oxygen oxygen R R oxygen R and R. This is called ozonide. This is a melanoside. This is ozonide. This ozonide under reacting with lithium aluminum hydride, alcohols are the product will be formation takes place, and paracids they gives acids are the products. So when we compound reacting with first one reacting with hydrolysis, then this reacting with hydrolysis, the bond breakage takes place. Then the product is in reacting with hydrogen. Sorry, when reacting with hydrogen, the bond is breakage takes place. Then the product is oxygen and here OH, here OH, R. When this compound involves in the breakdown of the compounds, then gives two carbonyl compounds, 2 moles of carbonyl compounds, and water is the product will be formation takes place. This is the ozonolysis. In this ozonolysis, the intermediate is melanoside and ozonide. This ozonide is breakdown with the hydrogen, then forms carbonyl is the product. Simply we are rating like this. Breakdown here, we are introducing oxygen both sides, then forms this compound. Next one is oxidative cleavage of 1,2-diols. Oxidative cleavage of 1,2-diols. Oxidative cleavage of 1,2-diols. One comma two diols. One two diols. When alkene reacting with KMnO4 followed by hydrolysis. Cis 1 comma diols are the product formation takes place. Cis 1 2 diols are the formation takes place. This is 1 2 diols reacting with lead state, tetrastate, tetrastate. Then the product is two carbonyls are the formation takes place. Mechanism for this reaction is lead, OAC, 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 and OAC. And it is involved in the elimination of 2 moles of acetic acids, 2 moles of acetic acid, then forms a intermediate will be formation takes place. This intermediate undergo cleavage takes place. Then forms 2 moles of carbonyl compounds and lead acetate. Lead diestate will be formation takes place. simply break down here, introducing one oxygen atom, one oxygen atom. So this is a uh, oxidative cleavage of 1,2-diols with the latest state. This is the topic of um, functionalization and functional group interconversion and oxidation of alkanes and alkenes. Next, we are going to discussing unit two. Unit two. Next, we are going to discussing unit two. That is oxidation of alcohols. Oxidation of alcohols. Discussing oxidation of alcohols. Mainly, alcohols undergo oxidation to give carbonyl compounds are the products. Alcohols undergo oxidation. Alcohols under oxidation mainly gives carbonyl compounds, minorly gives acids. This is a major product. The very minor product will be formation takes place. Mainly, they gives carbonyl comp. Alcohols gives carbonyl compounds are the products. So this oxidation of alcohols to carbonyl compounds, different reagents are we are used. One is chromic acid and Johnson's reagent, PCC, pyridinium chlorochromate, pyridinium dichromate, oxidation with alkoxysulfonate salts and op- openar oxidation. First, we are going to discussing oxidation of alcohols to carbonyl compounds when we reacting with the chromic acid. When the chromic acid is when all alcohols under oxidation with the chromic acid, Na2Cr2O7 and H2SO4, we are getting chromic acid. The structure of chromic acid is H2CrO4 is the chromic acid. That then we are getting carbonyl compounds are the products. Carbonyl compounds are the products. When primary alcohols gives aldehydes, when primary alcohols gives aldehydes, right? Secondary alcohols gives ketones. Tertiary alcohols does not undergo oxidation. No oxidation with takes place with the reagent. Okay. Next, we are going to discussing an example for this reaction is CH2OH primary alcohol reacting with chromic acid. Then the product is aldehyde is the product. This is a primary alcohol. When I am taken secondary alcohol with chromic acid, then the product is ketones are the product. This aldehyde, this is a ketone will be formation takes place. So next one is Johnson's reagent. Next one is oxidation of alcohols with chromium for oxidants. Next one is oxidation chromium 6 oxidant pyridinium complexes. This is PCC and PDC. Pyridinium chlorochromate and pyridinium dichromate. So how to prepare this pyridinium chlorochromate means when pyridine reacting with HCl, pyridinium chloride will be formation takes place. pyridinium chloride is the formation takes place. This pyridinium chloride reacting with the chromium trioxide, chromium trioxide, they attack it here and bond going to shift into oxygen side. Then the product is chlorine, double bond O, chromium O minus. Then the product is pyridinium. So this is a pyridinium chromate. Pyridinium chlorochromate. So PCC. And PDC means when this pyridinium chloride, reacting with Na2Cr2O7, Na2Cr2O7, elimination of 2 moles of HCl's, then forms pyridinium bicarbonate. Pyridinium bicarbonate is the product will be formation takes place. PDC, pyridinium dicarbonate, PDC. Pyridinium dicarbonate is the PDC. This PCC and PDC. This PCC, PDC, manganese dioxide, and silver carbonate or oxidizes the allylic OH, benzylic OH groups, benzylic, allylic OH groups, and allylic, that means allylic alcohols and benzylic alcohols are only oxidized by the PCC, PDC, MnO2, and silver carbonate. Best example I am taken here. This allylic alcohol. When this allylic alcohol reacting with PCC or PDC or MnO2 or silver carbonate, this allylic alcohol is oxidized to carb carbonyl compound. Acraldehyde will be formation takes place. When benzylic alcohol same reacting with PCC or PDC, then the product is benzaldehyde is the product will be formation takes place. So these are examples of this compound. Next one is oxidation of alcohols with the alkoxonium salts. Alkoxonium salts. This is one of the famous reaction is there. One of the important reaction is there. What is Swern oxidation? What is Swern oxidation? This Swern oxidation. Swern oxidation. Swern oxidation. That is the there is a DMSO oxaloyl complex. Swern oxidation. Thus, in this Swern oxidation is that is a Swern oxidation is alcohols reacting with the DMSO dimethyl sulfoxide and CO2 Cl2 CO2 Cl2 oxaloyl chloride, then presence of base pyridine like when the product is aldehyde is the product will be formation takes place. Alcohols converted into carbonyl compounds. It's a primary alcohol, that is a aldehyde. If I am taking secondary alcohol, same DMSO CO to Cl2 base, then gives ketones are the products. Ketones are the products. I'm telling the mechanism for this reaction. I'm telling explain the mechanism for this reaction. When uh, dimethyl sulfoxide, when DMSO reacting with oxaloyl chloride, here this pi bond shifting the elimination involves in the elimination of Cl minus, then the product is SO S plus O, double bond O, double bond O, Cl. So entire chlorine atom is there. This molecule involves here in this molecule. Next, it is involves in the elimination of carbon dioxide, carbon monoxide, and a chlorine coming here. Then the elimination of carbon dioxide and carbon monoxide. Then the product is C plus Cl. Overall Cl minus is there. When this compound reacting with alcohols, first it is involves in the elimination of HCl, elimination of HCl. Then the product is positive charge LCl minus. When reacting with the base, when reacting with the base, finally base abstract the proton from here. Base abstract the proton from here. Then the product is negative charge. This negative charge involves in the elimination of ketone, involves C double bond O, R, R, and dimethyl S, S here chlorine will be formation takes place. This is a byproduct will be formation takes place. Okay, no need to byproduct. So this is a product will be formation takes place. Okay, this is a ketone is the formation takes place. So this is Sven oxidation. Next one is oxidation of alcohols with manganese dioxide. Oxidation of alcohols with manganese dioxide, MnO2. MnO2. I am telling already allylic alcohols are undergo oxidation with manganese dioxide. This is allylic alcohol converted into aldehyd is the product. Okay. This is one of the example. So another example, one important example here, when allylic alcohols reacting with a manganese dioxide followed by reacting with methanol in Cn minus, the product is ester will be formation takes place. So mechanism for this reaction, when reacting with MnO2, alcohols are converted into aldehydes, carbonyl compounds. When this carbonyl compound reacting with Cn minus, cyanohydrins are the formation takes place. Cyanohydrins are the formation takes place. These cyanohydrins are the formation takes place. This cyanohydrin again reacting with MnO2, alcohol is here, alcohol is there. That alcohol also again converted into carbonyl compound. Carbonyl compound. When this compound reacting with the methanol, H plus O minus is substitute replace the Cn minus. HCl is elimination takes place. Then the product is methanol ester will be formation takes place. This is the mechanism for the oxidation of MnO2. Next, oxidation of silver carbonate. Oxidation of silver carbonate. When the silver carbonate syn it is oxidized the allylic and benzylic alcohols. It's a allylic alcohol and react with silver carbonate. then the product is acrylate is the product will be formation takes place when this if the compounds having two alcohols, if two hydroxy groups, when reacting with silver carbonates in presence of chelate, then the product is one of the alcohol undergo oxidation takes place, another alcohol is there. That means the secondary alcohol, primary alcohol. That means secondary alcohols are more reactive than primary alcohols. Okay. That's and one important is we know already. So PCC, PDC, and MnO2 and silver carbonate are oxidized as the allylic and benzylic alcohols. Allylic alcohols are benzylic alcohols more reactive than secondary alcohols, more reactive than primary alcohols. This is a very, very important for this topic is oxidation order of PCC, PDC, MnO2 and silver carbonate. Allylic and benzylic alcohols are allylic alcohol or benzylic alcohol more reactive than secondary alcohol than that of primary alcohol. This is a more very, very important concept in this oxidation. Last one is open hour oxidation. Open hour oxidation when alcohols reacting with triiso when secondary alcohols reacting with the aluminum isopropoxide, aluminum isopropoxide, aluminum isopropoxide, aluminum isopropoxide, then in presence of acetone is solvent, then produces ketone is the product. That means secondary alcohols reacting with aluminum isopropoxide in presence of acetone, then the product is ketones are the product will be formation. The secondary alcohols then gives ketones. This is the open hour oxidation. So open hour oxidation. So this is a topic of oxidation of alcohols. That is we are discussing oxidation of alcohols with chromic acid, H2CrO4. Then this chromic acid. So primary, secondary, tertiary alcohols are the alcohols. Primary alcohol aldehydes, secondary alcohols carbonyl compounds will be formation takes place. Tertiary alcohols are no reaction. When we reacting with the coming to PCC, PDC, and MnO2 silver carbonate, allylic benzylic alcohols are more reactive than primary alcohols, secondary alcohols than primary alcohols. So this is the topic of oxidation of alcohols. Thank you.